Welcome to Lesson 1, Part 2, Radical Functions and Transformations. So today we're going to learn how to determine the equation of a radical function. Now there's two methods that we can use to figure out what the equation is, and both of those are comparing to the original base graph y equals root x. So the y equals root x graph has that set of image points 0, 0, 1, 1, 4, 2, 9, 3, 16, 4, etc. And what we can do is when we're given g of x, we can draw that original f of x graph, y equals root x, onto our graph and compare it to the new graph and see what's happened. So you can do this by either comparing and looking at the vertical stretch to determine A, or you can see the horizontal stretch to determine B. Now, in this example here, we have our original graph f of x, and we can see that this point, 1, 1, is now 1, 2. So our vertical height has doubled. You can see it here as well in 0.42, which is now 4, 4. So that tells us simply that A has a value of 2. All the y values are twice as big as they used to be. The horizontal graph, it's much the same except you're working across the x-axis. So in our original graph, we're going to look across. So on our original f of x, this point 4, 2, on our g of x, it now becomes 1, 2. So you can see that it's changed by a factor of 1/4, which means, of course, that b is equal to 4. Don't forget that b has that little trick where we have to take the reciprocal of whatever's there. So this function can be expressed either as y equals 2 root x or y equals root 4 of x, and both of them would draw the exact same graph. Now, the second method uses a substitution of a coordinate of a point. So we would pick a coordinate on g of x and see how it has changed to determine the stretch factor. So if you're doing it as a vertical stretch, you can, for example, we're using the coordinate 1, 2 from that original g of x graph. So here we're just going to substitute 1 for x and 2 for y in the equation and solve for a. So you can see here we've put 2 and 1. Find the square root of 1, which of course is 1, and 2, and then just solve for a. 2 divided by 1 is of course 2. So that gives us the same result, y is equal to 2 root x. The second thing that we can do is view it as a horizontal stretch. So we're substituting the same coordinates in, and we're just solving for b in this circumstance instead. This one's a little bit trickier, but if you work carefully, you can get the hang of it. So for example, we have y equals root bx. 2 equals the root of b times 1. Of course, 1 times anything is just itself. So we're left with 2 equals the root of b. And then, of course, to undo a square root symbol, we would square both sides. So we have 2 squared equals the root of b squared, and 4 equals b. So then we can express that equation as y equals the root of 4x. If there are h and k values in the graph, so if your graph is starting at any point other than the origin, it will be very clear because this y equals root x has that base point of 0, 0. So wherever the graph starts and has moved to, you'll be able to see the h and k values very clearly. If you do have a horizontal or vertical shift, you must include those when you're solving using this way, otherwise your equation won't work. And I'll show you what I mean in the next example. So let's focus in on the graph first, and then we'll talk about the method 2 substitution. Now, I want you to remember that y equals root x starts at the origin, 0, 0, and therefore the starting point of the graph will allow you to determine h and k. So on your paper, you can see we've gone 1, 2, 3 down. That's our k value, -3. And we've gone 1 to the right, so our h is 1. Now, the same thing that we did in the example, we're going to look at how has the x and y values changed to determine what our graph would be. Now, if we look at it as a vertical stretch, we're going to see how has the height of a point on the graph changed. So we have this original g of x graph at 5, -2, and we're going to compare that to our f of x, which is y equals root of x, and then shifted down and over. And here we have y equals 1, -1. So at this time, you can see that the change in the y values is half of what they used to be. They've gone from 1 down to 2. Now, if we look at it as a horizontal shift, you're going to compare that same point here to the original graph here, f of x, and we can see that our b values have changed by a factor of 1/4. Our x coordinates have changed by a factor of 1/4, giving us a b value of this. If you're looking at it as a vertical stretch, you can see you have your a value here, which affects the y's. If you're looking at it as a horizontal stretch, we have our b value here, which affects your x's. Now, if we go and look at that method 2, remember I said in the last sheet that if you have h and k, you must include those values in your equation to solve, otherwise you'll get a wacky answer. So we're going to use that same point, 5, -2, and we're going to use that general formula, y is equal to a root of x minus h plus k. So we're going to consider the vertical stretch at this time. Now, all we're doing is just plugging in the values that we have. So we know h is 1, we know k is -3, and we have this point, 5, -2. So -2 is equal to a square root 5 minus 1 minus 3. Now we're just going to solve for a. So I've added 3 to both sides here, and then I've solved for under the square root symbol, which is root of 4, a root of 4. Now -2 plus 3 is +1, and a times 2, because the square root of 4 is 2. And then just divide both sides by 2 to get 1/2 equals a. Alternatively, we can determine the b value instead. So we have y is equal to the square root of b, x minus h plus k. We're going to use that same point to determine it, and you'll see the consistency in the answer. So we have -2 for our y is equal to the square root of b, 5 minus 1 minus 3. And then again, simplifying. So here we've got -2 plus 3. That'll give us +1. And then you might be a little bit confused about what's going on here. I just wanted to remind you that underneath the brackets here, we have 5 minus 1, which is 4. All I've done is factored that the square root of that out to put it on the outside of the brackets so that we can manipulate it onto the left-hand side of the equation. So the square root of 4 is 2. If we're think of it like dividing it out. So we're taking it outside the square root symbol. It's there now. Root b. This will allow us to isolate the b. So we have 2 times the root of b. We're just going to divide both sides by 2, and we'll get 1/2 is equal to root of b. And then to get rid of a square root symbol, you just need to square both sides. So 1/2 squared is, of course, 1/4. and the square root of b squared is b. And you can see that that corresponds to our equation that we found by looking at the horizontal shift. Beyond this, you have a couple practice questions, and you should do your best to complete those for class tomorrow.